Imagine, if you would, the challenge of sending a few hundred colonists on a multi-generational spaceship bound for a distant planet. Also, this is at a time when long-term hibernation isn't quite yet perfected. How would you prepare a few dozen people to cover the engineering, medicine, and technical tasks involved in maintaining the ship over such a long voyage, especially where the systems are bound to fail? Well, AIs are far from infallible, and without the cortical download available to the characters in the Matrix movies, training a few people to fill thousands of roles isn't a viable option. Better for the people to operate and monitor the devices that they use every day, and in so doing, use their decision-making to maintain the complex systems aboard the ship. With that hypothetical in mind, I'm going to show you how the low-tech appliance, a common toaster, can be used to monitor and control a simple plant irrigation system. The enabling technology that makes this possible is translational reality, which you can read about in more detail on the Translational Reality website. Let's start off by considering a typical user interaction with a toaster. The user drops in 1 or 2 slices of bread in a toaster, selects the doneness or darkness setting, and presses down the lever to load the bread and start the heating process. The circuitry in the toaster determines when to release the lever and present the toasted bread to the user. Now, consider an irrigation system where the user selects the desired moisture level of the soil by interacting with a controller. The controller activates the driver, which causes the pump to circulate water to the soil surrounding the plants. A sensor in the soil is used by the controller to determine when to stop the pump. Now, let's consider the system with a translational reality interface. The two systems are now linked, and the darkness setting on the toaster controls the pump directly. Similarly, the controller determines the darkness of the toast, that is, not the setting on the toaster itself. Here's a photo of the complete working system, with the moisture sensor visible at the rim of the plant pot. Note that the toaster is normally isolated from the plant, and that the toaster operator cannot directly observe the status of the plants or irrigation pump. Now let's step through the system. The operator sets the desired darkness of the toast, and that is translated by the controller to drive the water pump at a specific rate and duration. Here, the sensor communicates the moisture level to the controller. The more moisture, the lower the resistance reported by the moisture sensor. If the soil is abnormally dry, the toast is overdone. Similarly, if the soil is abnormally wet, the bread is returned untoasted. Again, here is the completed system. If you're a techie, you'll probably be interested in the connections to the toaster PC board shown here, and the Arduino controller here, and the pump with driver shown here. If you'd like to see the Arduino source code and the circuit schematic, see the article in the March 2017 issue of Servo Magazine, which I edit. If you have any questions about the more practical applications of the underlying translational reality technology, see my contact information below or at translationalreality.com. Thanks for watching. I'll be uploading other demonstrations as time allows.